Okay, let's connect. Let's get full screen here. I'm not sure about full screen. All right, so I'm going to do the worksheet that you were working on in class today. So that I'm not here all day, I'm going to do it very quickly, but you have the ability to stop and look at the calculations. A lot of times the numbers speak for themselves. Right, but I am going to hold down the explanations to a minimum. So X1, first question was the equation of a line through X1, Y1, and X2, Y2. And I just wanted to give you a little feeling for a formula. So the answer to that is you start with an X, you get rid of the first X, and you bring in the first Y. Then you have to get rid of the first Y to bring in the second Y. That's why that's in the numerator. And of course, that's the change in Y, and certain changes of X's produce those constant changes in Y's. All right, so that's problem number one. Problem number two. Intercept form of a line. So Y equals -7/4 X, parentheses, minus +5 + 11. All right, so I'll just do this out and you can look at the numbers. So we're multiplying our entry level numbers by -7/4. We're subtracting 35/4, and 11 is 44/4. So final answer, -7/4 X plus 11/4. And you can look at the mechanics of that. Freeze frame it. Number three, sorry. Name three coordinates. Y - 12 equals -1/7 X plus 2. If I let X equal -2, the right side of the equal sign is 0. If I let Y equal 12, I'm sorry, the right side equals 0 when X is -2. And when I put a 12 in for Y, the left side is equal. So that means that -2 matches up with 12. Now we go to the slope, we change our X's by 7. We could do that forever. We go down 1. Okay, you freeze frame this. And hopefully think about it. Maybe you'll put that concept in your pocket. So I think I'm on 3 or 4. I don't know. So I guess number 4. 4a squared minus 16b squared, we're going to write as a product. It's a difference of two squares. The difference of two squares is a squared minus b squared in the Algebra 1 textbooks is a plus b times a minus b. All right, so you can check that with numbers. 9 minus 4 is equal to 3 plus 2 times 3 minus 2, for instance. Those are true statements. And these are square roots of the area. But I gave you this one because the first rule of writing products is take out what's common, which in this case is 4. And 4 times a squared gets us the first term. Minus 4b squared gets us the second. And now we have the difference of two squares again. Any difference can be written as the sum of the square roots and the difference of the square roots. But this one becomes a plus 2b times a minus 2b. For all numbers. That could have been written this way. All righty. Now we've got two lines intersecting and we want to find the x value. So I'm just going to do it mechanically. Minus x minus 9 equals 6x minus 27. I think the sharpest way to solve this is to say 7x equals 18. 18 divided by 7 isolates x. Minus x minus 9. Let's call that minus 9 minus x, something like that. 6x minus 27, up 6 over 1. We can see that they intersect there at a small x positive value. That's what it was. All right, probably the most important problem on the sheet. 35x squared minus 21x. The way it's currently written, you cannot use inverse operations the way it's currently written. We have a linear and a quadratic term. We can't put them together. But the way out of this problem is just to factor out x. 35x minus 21. And writing products equaling 0 is going to be a very important skill that you're gonna remember how to do coming out of this class, or I'm gonna really work hard to make that happen. Now I can see that if something times something equals 0, one of the parentheses has to be 0. So, or one of the factors. So if this is length and this is width and this is area, how do I get rid of that length? By letting that value take on 0. How do I get rid of the width? X would be 21 over 35, right? We want to get quick at doing 35x minus 21 equals 0. 2 inverse operations. We don't want to have to struggle with that. We don't want to have to write that out. We want to look at that and be able to say that works. Look at that and be able to say that works. Now, in the context of the graph, let's put this as a graph and this, let's separate it. 35x squared is a narrow parabola. Minus 21x in this case is going down. Well, I'd have to put it on this side, right? Going up steeply. They intersect at 2 places. One of them is 0, and the other right there, 21 over 35 for x values. If you want the y value, you got to plug in 31 over 25 here to find that y value. We know that one's 0. I'm talking more than I said I would. You replay anything. All right, minus 4x over 5. Again, we're still in the algebra 1 domain, plus 3. Have to teach this at all levels. So don't feel bad. Minus 5 halves x, minus 5 halves x. I wish my brain could remember these things. 1. All right. So the quickest way out of this is to get rid of the fractions. If I multiply everything by 10, now 1 plus 2 equals 3. If I multiply everything by 10, I still get truth. All right, so I'm going to multiply everything by 10. If I multiply this by 10, I get minus 8x. And I hope you can see that 5 goes into 10 twice. Here I get 30. 2 goes into 10 twice. Minus 25x. Then 10 times negative 1, negative 10. Remember, you can freeze this and just look at it. And get rid of that. All right, so I'm going to bring the 25 this way, 17x. I'll bring the 30 that way, minus 40. And so there x is minus 40 over 17. Again, these 2 lines intersect, and that's the x value they intersect at. So whenever, I should put a bracket there. Whenever you're solving an equation, you're looking for the intersection of 2 graphs. I think I can make that blanket statement until I find something that disproves it. All right, so that's that one. Next question. Again, from Algebra 1. X minus y equals 2. I hope everybody has the elimination method down in their memory bank somewhere. So x minus y equals 2. 2x plus 2y equals, come on, 16. All right, so I now know from practice that a subtraction x minus y is actually an increasing function, and a plus is a decreasing. And we're trying to find that x, and we're trying to find that y in this problem. We're trying to find the coordinate of intersection. So I'm going to double the top equation, 2x minus 2y equals 4. And I am going to leave the bottom one alone. We did this together in class. Most of us did this. And now when I add up the column, the y's cancel, and I get 4x equals 20. So therefore, this is x equals 5, intersection x equals 5. Right, 20 over 4, yes. And if I plug a 5 in here, 5 minus what is 2? 3. So I know I have 2 lines intersecting at the coordinate 5, 3. That'll be on every test the rest of the semester. Might not be integer friendly, but 3x squared minus 30x minus 11. 3x squared minus 30x minus 11 is a y statement, and we're going to write it in a more user-friendly form. We're going to start by getting the first term. There's 3x squared. Yep, I got the first term. Your memory banks have to kick in. How do you find the vertex? That's all you need is the vertex, an x and a y here. All right, you pause the video and think. I'm just going to keep doing it. So minus b over 2a. Minus b over 2a is how we find the x. So in this case, that's positive 30 over 2 times 3, which is 6, which is 5. I want to make 0 squared. I don't want 5 squared, so I say minus 5. If I do this out right now, I get 3x squared, double that, minus 10 times 3 minus 30x, and I get 75. You know, it's almost the same thing, except that these numbers don't match. But I know how to get 75. I know how to make it negative 11 by subtracting 86. Now they are the same thing. Now how can you get that minus 86 another way? Well, there's another way you could get it. You could plug 5 into the original equation. And if I do, I get 75 minus 150 minus 11. And if you take your time with that, that's negative 86. That's another way to get it. But now I know, expanding this, that becomes minus 11. And by golly gee, it's the same as what I started with. And that's called completing the square. And completing the square is all about the area of a rectangle on the left being squished into a square, which gets you the first 2 terms, and adding an adjustment so that the calculations are equal. That's what's going on. And so now I know what this graph looks like. I know the vertex is 5, negative 86. And I also know that a 0 gets me boom, 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 negative 11. And this is a standalone question too. How do you write this equation to get it back into that form? You got to figure this out. Okay, well, that's not hard. X minus 5 squared minus 86, that's not hard. Question is, how do you get the number 3? Well, it might be easier if I put a 10 over here and a negative 11 because of the symmetry. You might understand it. So let's start at 5 and let's go a change in X. Let's go far enough so that when I square it, and 5 to 10 is actually a change of 5, and when I square it, I get 25 units of area. But that's not enough to get me to negative 11. So I don't want that 25. I want the number that takes me from negative 86 to negative 11, and that's 75. Oh, that's where that 3 is coming from. Rise over run squared. Oh, because this is run in the common vernacular and it's being squared, I have to cancel that in order to make these numbers work. And the beauty of this over here is I can solve equations now with inverse operations. In other words, let's say I want to know when this hits a height of 0. I'm at negative 86. The first thing I got to do is climb 86 units, but then I'm multiplying by 3. So I got to divide by 3. Of course, then I'm squaring. So I got a plus minus square rooting, and I'm measuring from the number 5. Remember we said you had to move a certain amount? And what that amount is the square root of 86 over 3. Now, what do you get when you square that? You actually get 86 over 3. Yeah. And what if I triple that? I guess you get rid of the division by 3. Looks like I'm going up 86 units to hit a height of 0. It does work, doesn't it? And I'm talking more than I said I would. All right, let me just zap out the rest of those problems. Otherwise, I'm going to be here and miss lunch. I don't want to miss lunch today. I hear it's the best lunch of the year. Perpendicular for a 53x plus 2y equals 19. Well, if somebody didn't draw the perpendicular, let's say that's 2 to 1. 2 to 1 ratio. That's a slope. The multiplier would be, you give me 2 units of change in x, I'll give you 1 vertical change. Let's draw a perpendicular. I'm guessing perpendicular is probably, I don't know how close to 90 degrees I got, but let's look at what this is. This is over 1 and down 2. So the new slope, the perpendicular slope, is rise over run minus 2 over 1. The original was 1 over 2, which was positive. The reciprocal changed signs, and rise over run became run over rise. Interesting. So I guess this hinges on finding the original slope of that line. And I don't think anything here has anything to do with a constant. It's the interplay of these two numbers, these two terms. And 2y equals minus 53, sorry, minus 53x, maybe I should write that a little better. So 2y equals minus 53x, and therefore y is equal to negative 53 over 2 times x. So the original slope is minus 53 over 2. So what's the new slope? 2 over 53. Right? If one's going down, the other's got to go up. And I want it to pass through the point, come on, 4, 7. So I want this to pass through 4, 7. That's not hard. X minus 4 plus 7. You plug the number 4 in there, your y value becomes 7 because I made the product 0. I can't highlight that enough. Products equaling 0. Very useful. Gets us out of a lot of jams quickly. It doesn't get us out of jams, it just allows us to see numbers that work quickly. All right, so that will be on your test on Tuesday. Will you have had enough time to memorize it? Probably not. People make mistakes on that for weeks. All right, inverse. Oh, we haven't done this a lot. You might not have known that that means inverse. Well, I'll do the textbook method for finding inverse this time. It's really looking at the steps involved in solving for numbers. So what would be the first thing you do if you were solving for a given number? You'd add 4, divide by 2, take a cube root. So what is the inverse? So this is the original function, and we are going to find the inverse. I'll do textbook. F of x is another way of saying y equals 2x cubed minus 4. Inverses is switching your x's and your y's, where instead of doing things to the x values, we're doing them to the y's. And now solving for y requires several steps. Okay, we're at the inverse stage now. So the inverse is the cube root of x minus 4 over 2. Now the way you check to make sure you did things in the proper order is to pick an x value. I'll let x equal 2. 2 cubed, 8 times 2, 16 minus 4 is 12. So up here, a 2 gave us a 12. If I switch the x's and the y's, a 12 should get us a 2. Can you see that? Yes, you can. So let's put 12 in. 12 minus 4 is 8. 8 divided by 2. I made a mistake here, you see. I made a mistake. I did. See, it's a good thing I checked that. Boy, oh boy, what a dumb mistake talking. Minus 4 becomes what on the other side? Plus 4. That's why you do that. So you find these mistakes. So now 12 plus 4, 16 divided by 2 is 8. And the cube root of 8 is 2. Now it works. Okay, so that's why I do that. If I was not talking, maybe I wouldn't. Who knows? But because I'm talking, I'm sure I'm going to make more careless errors later in the video. So if you catch them, just tell me to stop, and then I'll pause and I'll erase. Oh no, I can't do that because this is recorded. Okay. Now we've got g of x equals 5x minus 2. So we're going to do g of minus 2/3. Just making sure your fraction work. Hopefully in algebra 1, you know, this is, if you don't know what to do with that, well, a little bit of a gap, let's close it. I am now assigning the letter x a specific value. So I'm going to take that specific value and multiply it times 5, and then I'm going to subtract 2. So that's minus 10/3 minus 2, which is minus 10/3 minus 6/3, which is equal to minus 16/3. And you can pause that, look at it. Next one. Now it says g of x equals 1/9. G of x equals 1/9. All right, and g of x may be written as 5x minus 2. Oh, well then instead of saying g of x, why don't I say 5x minus 2 equals 1/9? And let's find the value that produces that table value. I strongly suggest you multiply everything by 9. 45x minus 18 equals 1. I don't like fractions. Oh, I can see 45x equals 19. I can see my x value is 19 over 45. A little trick of the trade. Stay away from fractions. Get rid of them. So division by 9 on this side is the same as multiplication by 9 on that. That's what I did. All right. Let's see what's next. State the constant conversion ratio. Well, it's really just finding slope-intercept form, right? So 3y equals minus 4x plus 7. So y is equal to minus. I could stop right now. I found the conversion ratio, but I'll do the rest of it. All right. So what's the ratio? You give me $3. Is that what I want? And I'll take 4 away. How do I want to say this? Can't think of a proper way to say that where I make enough money here. Well, oh, I'm sorry. So the conversion rate was 3 to -4. So in other words, if you go over 3, you're going down to 4. If you go over 30, you're going down to 40. It's still on the line. Okay, it's a ratio of change. A ratio of -4 to 3. No, that's how your table values are changing. X's are getting bigger by 3, Y's are going down by 4. Oh, products equaling 0, x squared times. Let's get this up. Maybe I can get one of those things that fold it up. Yeah, I'm going to check out that situation right after I do this problem. 3x minus 7, x plus 4, x plus 5 over 6 equals 0. All right, think of this as a multi-dimensional shape. I know we can't draw more than 3 dimensions, but you can imagine that each of these is a dimension, and if you squash one of the dimensions, you squash the volume, the area, the whatever comes from a 1, 2, 3, 4, 5th dimensional picture. Anyway, x squared could equal 0. 3x minus 7 equals 0, so on and so forth. So when is that 0? When x is 0. When is that 0? When x is 7/3. When is that x? -4. What makes that fraction equal 0? -5. So this thing had 1, 2, 3, 4 x-intercepts. If I put that in Desmos, it cuts through the axis at those x values. Simplify the square root of 75. What's the square root of 75? Well, the easiest way to rewrite that is the square root of 25 times the square root of 3, which is equal to 5√3. That's your final answer for that one. You're all hovering around algebra 1, folks, trying to close any gaps. But algebra 2 is just making sure you don't have gaps from algebra 1. So maybe we're doing it. 5 minus 4i. I will do it out over here as a parentheses, but there's really no need. So 25 minus 40i plus 16i squared becomes 25 minus 40i minus 16, which becomes 9 minus 40i. I'm done. I'll do it out over here. 5 times 5, there's your 25. 5 times minus 4i minus 20i. Again, I'm doing it again, another minus 20i and a positive 16i squared. And I think you can see how that morphs into this side. So pause the video if you need more time to look at it. Minus 2 times x plus 7 squared plus 1, we're going to expand. If you need to do x plus 7 and x plus 7 over here, go ahead and do it. Now, this is going to get you minus 2 times x squared plus 14x, doubling that positive product, plus 1, I'm sorry, plus 49, right? You got to square the 7. Do a bracket, plus 1, okay. minus 2x squared minus 28x, I'll do this in my head, minus 98 plus 1 is minus 97. Right? It's going to be on your test on Tuesday. Yep, you know what your test's going to be. I'm handing it to you. It's right here. And whatever else I forgot, like distance. I know distance between 2 points, a little Pythagoras isn't on this one. It will be. So 2x squared minus 50 equals 0. Can I isolate x? Can I isolate it? Sure I can. Adding 50, dividing by 2, taking the plus minus square root of 25, which gets me plus minus 5. Right, 2x squared, this is 0 when x is 0. So that is actually your vertex is at 0, negative 50. And it's a cup shape up. That's positive 5. That's negative 5. That's what Desmos would show you. I've gone past midterm lots of times before classes can do that. 5x squared plus 20 equals 0. Well, looks like I'm subtracting 20. Looks like I'm dividing by 5. Looks like I'm plus minusing the square root of negative 4, which is actually plus or minus 2i, because the minus sign you write after the radical, so that the reader knows that there really is no point of intersection here. 0 is the x-axis. This is the height of 0, y equals 0. Right, and 5x squared plus 20 is again a narrow parabola. What makes 0 here? 0. So 0, 20 was the vertex. Does that graph intersect the x-axis? You'd be imagining things. You'd be imagining it coming down in the other direction, and it would intersect at negative 2 and positive 2, but you're imagining that. That's what's going on. Now, you may need to pause the video. Think about it at your own pace. And I'm just going to keep moving along. What's the y-intercept for y equals 2, x minus 3 plus 4? Well, how do you find the y-intercept? You'll hear me say this quite often. Let x equal 0 to get a y-intercept. So we let x equal 0, and if we do, we get 2, 0 minus 3 plus 4, which is 2 to the negative 3 plus 4. 2 to the negative 3 is 1 over 2 cubed by definition. So what's my final answer? My y-intercept, when I put a 0 in, is 4 1/8. That's the y-intercept. Maximum value for a quadratic with a negative a value. And we're trying to find the maximum. So we're looking at the calculation minus 3x squared minus 12x plus 7. What's the biggest y value? The biggest one that can come out of this? Well, I know it's cup shaped down. And I know how to get the x value for that particular location. And yes, minus b over 2a should have come into your head at some point, I hope. The opposite of minus 12 is positive 12 divided by 2 times negative 3, and that's negative 2. So now I'm going to plug negative 2 in order to get this maximum value. All right, so negative 2 squared is 4 times negative 3 is negative 12. Negative 2 times negative 12 is positive 24. Plus 7 is the same thing as adding 12 plus 7. Looks like the max was 19. That's what you'd write down. All right, now we're getting some problems we have not practiced very much. That means probably going to have a little difficulty with these for a while. Log base 27, 1 over 81. Okay, you know what you're being asked to do. You're being asked to find the exponent on top of the 27. That gives us 1 over 81. But we only have exponential rules when the bases are the same. So can I find a common base? 27 is 3 to the 3. And I'm guessing 1 over 81 is 1 over 3 to the 4. Of course, there's an easier way of writing 1 over 3 to the 4. And that is 3 to the negative 4. Because that's what it means. I know my rule of exponent, do you? That's a product. Then know the inverse, the multiplication is division. So is it true that if I put negative 4/3, that I will get that answer? Now, what's the first thing I'm going to do? I think I'll take the cube root of 27. I think the cube root of 27 is 3. Oh, yes, 3 times 3 times 3 is 27. Yes, so the cube root of 27 is 3. That leaves 3 to the negative 4. Oh, we already talked about that. 3 to the negative 4 is actually 1 over 3 to the 4th, which is 1 over 81, 27 times 3. So this final answer was the exponent negative 4/3. Yep, 27 is, well, I already did it. So pause the video, go back, play that. Those questions will be on every test the rest of the semester. 16 to the negative 3/4. Oh, now you're actually using exponents. I don't want to flip it. I don't want to make 16 over 1, 1 over 16, so I'll do that later. I don't want to do 16 times 16 times 16. I don't want to do that. I don't want to do that. Let's hope this is helpful. Oh, that's the 4th root of 16. Is there a number times itself 4 times that gives 16? Oh, yes, that's 2. So I'm going to do this operation, which morphs into the 4th root of 16 is 2 to the negative 3. Let's just call that 1/8. We don't even need to talk about it anymore. All right. You play that back if you want. Let's see. Log 3. So that means I'm doing a 3 to the equals 1 over 243. Let's see. 3 times 3 is 9, times 3 is 27, times 3 is 81, times 3 is 343. 243. 81, yeah, 243. Oh, geez, if I do 3 times 3 times 3 times 3 times 3, I get 243. I did it 5 times. Oh, and that exponential activity, right? That exponential activity is in the denominator. So the exponent's negative 5. Yes, 3 to the negative 5 is equal to 1 over 243. Huh. Yeah, 1 over 3 to the 5 is the same as 3 to the negative 5. Oh, I definitely can see some exponential activity on top of 3 now to get that. Sure looks like they have to be equal. Yeah. Planting some seeds here. Right as a product. X squared plus 9x minus 22. You know, I've been doing some of these spoiling products. They seem to come out to these trinomials. Now, what are the factors of 22? 1 and 22, 2 and 11. Oh, bingo! 2 and 11. Yeah, I can get a 9 out of that. Yeah, I think I can add 11 and subtract 2. I think that gets me the product, negative 22. And I think 11x minus 2x gets me the 9x. I think that's telling me something. It's telling me that this graph, this cup-shaped graph, cuts through at 2 and at negative 11. Woo! Oh. Oh. 11 minus 2 is 9. 9 over 2 is 4.5. I guess that's the average of the roots, huh? 4.5. Oh, I guess that's minus b over 2a. Oh, yeah, minus 9 over 2. Seems to all come around and man, so much information. Now, what's next? 3 log, oh, exponentiating and logging, solving equations, yes. Guess I'll just have to do this one for you. I don't think I even have to talk about it too much. I'm going to subtract 9. 3 log base 2 x minus 4 equals 3. Subtracting 9, dividing by 3. Log base 2 of x minus 4 equals 1. Changing to exponential form. 1 is the exponent I put on top of the 2 to get x minus 4. Sure looks like x is 6. Subtracting 4 becomes addition of 4. Let's put the number 6 in and see if it works. 6 minus 4 is 2. Jeez. What's the exponent I put on top of the 2 to get a 2? I guess that's a 1. Now, the exponent on top of the 2 to get a 2, this is 2 to the 1. I guess I need a 1. And I'm multiplying that by 3, and I'm adding 9, and I guess that gets me 12. I guess the number 6 works. Name that tune. Well, you got to look at the x value. Name that tune. So we got a 2, 2, 4, 6, 8. Wow, that was easy. I think I could keep that pattern going. We got a 7, a 4, a 1, negative 2. You know, I see a constant change here. I see down 3, I see down 3, I see down 3, I see up 2, I see up 2, I see up 2, I see down 3 over 2, down 3 over 2, down 3 over 2. Sure looks like a line to me. I wonder if I can figure out how to write the equation of a line given 2 points. Because I think I got those 2 points right there. X minus 2 plus 7. X is changed by 2, y is go down by 3, and there's the equation that produced the table value you were looking at. Now, another way to do it, 2, 4, 6, 8, 7, 4, 1, negative 2 is to make a bar graph. So what I just did probably didn't come to you, but if you made a bar graph where you've got 2, 4, 6, 8, where I'm jumping the same distance, then you might look at up 7. You might look at up 4, it's a little more than halfway, up 1, and you might start to see the trajectory is lining up, which would lead you in the direction of what kind of calculation is this. So plotting the points is helpful, because then you get a shape, you see the shape, and we're going to get really familiar with the shapes of all of the graphs. Last one, vertex 4, 7. And it is going up 982. And it's a quadratic. Okay, so what can I say? 4, 7, x minus 4 squared plus 7 minimizes that area. Drop in a 4, you can't get anything smaller than 0 squared. Can't get below 0 when you square numbers, so that's going to be the vertex. And I'm going from 7 to 82, which is up 75. And if I go over 4 units to 9, I've gone over 4. 4 to 9, sorry, I've gone over 5. And if I square that, if I square 9 minus 4, I get 25 units of change. But I want 75. So I get rid of the 25, I bring in the 75, and I guess it looks like I'm tripling the squaring process. Tripling the squaring process. So if I were to go over 10, I should go up 100, so it'll take me to 107. So 14 should get me 107, I think. Let's find, oh no, I tripled the 100, 300. So it should get me 307. I don't know, it's the end of the video here, my brain's starting to get fried. Let's drop a 14 in. 14 minus 4 is 10, 10 squared is 100. So there's your 307, yep. All right, so you can get some quick table values once you understand what's, causing the trajectories in these graphs, the numerical trajectory. All right, so that's just one side. I think I'll do one more problem because it's going to be on Friday and I can remember it. Let's just find the distance between 2, 3 and 8, 5. Okay, dot to dot. Do you remember what to do? Over 6, up 2. I'll put it there so it looks a little bit more friendly. Boom, 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 boom. That distance, what is it? 36 units of area, 4, 40. So this is the square root of 40, which happens to be 2 root 10. Right? Square root of 40, square root of 4 times square root of 10, 2 root 10. I don't care about that so much as knowing the Pythagorean relationships and what you're getting from them. All right, so that's the video. I'm going to close down now and upload it.